Dear students, welcome to E-class learning program for mathematics of class 8th. Name of the unit is square sine square roots. This is divided into two sessions and today we are discussing for the first session. Dear friends, you know this is a square and its sides are 6 centimeter each. We want to find the area of the square and you know area of the square is length into length or side into side, which is 6 centimeter into 6 centimeter, which gives us 36 square centimeter. We will have one more activity here. Can you count the number of unit squares in this figure? Yes. Here you can observe there are 3 rows and 3 columns. So, instead of counting 1, 2, 3, 4, 5, 6, 7, 8 and 9, what we can do is we can multiply 3 with 3 and get 9. Yes, there are 9 unit squares in this diagram. Now, this is read as square of 3 is 9. Symbolically, we write it as 3 square equals to 9. So, let us have one more activity and you are very much familiar with this diagram because it is a chessboard and we all know that it has 8 unit squares row wise and 8 unit squares column wise. So, total number of unit squares is again as we did in previous case is 8 into 8 which is equals to 64 and we write this as square of 8 is 64. Symbolically, we write 8 square equals to 64. So, these 36, 9 and 64 are called perfect square numbers. How we got them? We got them a number by itself. So, students, please remember that integers refer to both positive as well as negative, but in this session as far as this chapter is concerned, we are discussing only about the perfect squares of positive integers. So, let us see the perfect square numbers of some natural numbers. So, let us take one, multiply 1 by itself, that is 1 and get 1 which is the product, and if you write this in n square form, 1 as a perfect square. Similarly, for 2 we get multiplied by itself and product is 4 and n square form is 2 square, perfect square number is 4. Similarly, for the next natural number, the product is 9 which is 3. Similarly, 4 square is 16, 5 square is 36. Now, you got the idea how we can get a perfect square number. Here I have just shown only the squares of 6 natural numbers. You can try as many natural numbers as possible to get a perfect square number. Now, let us have the perfect square numbers of first 20 natural numbers. Now, you notice one thing, with this table we can get certain interesting features of perfect square number. The first feature of these perfect square numbers is that look at the squares of odd numbers, that is 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19. If you observe them, these are all odd numbers and squares are also odd numbers. Square of 1 is 1 which is odd, square of 11 is 121 which is also odd. So, you take any odd natural number and consider its square number, we will find that it is also an odd natural number. Similarly, for the even natural number, its square is again an even natural number. So, what we can infer from this is that square of an odd number is odd and square of an even number is even. This is one of the most important features of the square numbers, perfect square numbers. Now, look at the second feature. Just consider the units digits of square numbers which are shown in red color. So, from 1 to 20 natural numbers are taken, their square numbers are written and square numbers unit digits are colored with red. What is the main purpose of doing this? Look at the digits which are appearing in the perfect squares of a unit digit. So, 1, 4, 9, 6. So, if you observe the units place only, you will observe that some digits are missing in the units place of the perfect square number and some are present in the units place of a perfect square number. Now, what are the unit digits of a perfect square number? Then digits in the units place of a perfect square number are, if you notice, 0, 1, 4, 5, 6 and 9. And what are the digits which are missing? Yes, you are correct. Digits that do not occur in the units place are 2, 3, 7 and 8. Children, is it possible to say that if a number ends with 0 is a perfect square, if a number ends with 1 is a perfect square, if a number ends with 4, 5, 6 or 9 is a perfect square? No. So, whenever a number ends with 0, 1, 4, 5, 6 or 9, it need not be a perfect square, but every perfect square end either with 0, 1, 4, 5, 6 or 9, any one of the digits among these 6 digits. But we can surely say that no perfect square will never ever ends with 2, 3, 7, 8. That is, units place of a perfect square cannot be 2, 3, 7, 8. So, we can surely say that any number with units digit as 2 or 3 or 7 or 8 is not surely a perfect square. So, one more feature of this table we can identify is that look at the units place of perfect square numbers of 1 and 9, 11 and 19. So, square of 1 is 1, square of 9 is 81, square of 11 is 121 and square of 19 is 361. These all perfect square numbers end with the unit digit 1. So, what do you infer from this? Yes, if a perfect square ends with 1, then the number whose perfect square is this number will ends either with 1 or 9. Can you find the similar relation between other digits of the perfect square in the units place? Yes, look at 4, 64, 144 and 324. 4 is square of 2, 64 is square of 8, 144 is square of 12 and 324 is square of 18. So, what do we infer? When a perfect square ends with 4, then the number whose perfect square is this number will end either with 2 or 8. The similar information can also be derived from the perfect squares ending with 9. Look at the square of 3, look at the square of 7, look at the square of 13, so 17. Look at their unit place of perfect square 9 is 9, unit place of perfect square 49 is also 9, units digit of perfect square 169 is also 9, and units digit of 289 is also 9. So, what are the numbers whose squares are these numbers? Yes, 289 is the square of 17 whose unit digit is 7, 49 is the square of 7 whose unit digit is again 7, but look at the 169 which is the square of 13, unit digit is 3. Similarly, 9 whose number which we got from the multiplying 3 into 3 units place is 3. So, what do we infer? We infer that if a perfect square number ends with 9, then the number whose perfect square is this number will have either 3 or 7 in its place. Similarly, a perfect square which ends with 6 will have either 4 or 6 in the units place of the number from which these perfect square are got. Look at the perfect square ending with 5 and 0. When a perfect square ends with 5, then you can notice that the number whose perfect square is this number will also ends with 5, and if a perfect square ends with 0, then the number from which this perfect square is got will also have 0 in its place. So, let us summarize these all things what we discussed so far. Now, we can say that if unit digit of n square and n are to be compared, if units digit of n square is 1, then the unit digit of n is either 1 or 9. If unit digit of n square is 4, then unit digit of n will either be 2 or 8. If the units place of a perfect square, that is n square, is 5, then unit digit of n is 5 only. For sixth, n square ends with 6, then n will end with either 4 or 6. If n square ends with 9, n will end with 3 or 7. Similarly, when n square ends with 0, surely n will end with 0. That means, it is a square of a number whose unit digit is 0. So far, we are discussing about perfect square numbers. Now, all of a sudden we got triangular numbers. What is the relation between these square numbers and triangular numbers? Let us explore that one. See, here how many triangles are there? Only one triangle. If we add 1 plus 2, we get 3 triangles. This is a triangular number. Now, again 1 plus 2 plus 3, it is 6. This is the third triangular number. Similarly, 1 plus 2 plus 3 plus 4 will give us 10, which is fourth triangular number, and finally 1 plus 2 plus 3 plus 4 plus 5 gives us 15. So, you go on finding the triangular numbers by adding the natural numbers starting from 1 consecutively. So, if you take only one natural number, then you will get 1. You will get sum of 2 natural numbers, you will get 3. Sum of first 3 natural numbers is 6, and so on. Now, is there any relation between these triangular numbers and square numbers? Yes. Let us add the first 2 triangular numbers, that is 1 and 3. Sum of first 2 triangular number is 4, which is square of 2. Let us take the sum of second and third triangular numbers. Second and third triangular number sum is 9, which is the square of 3. Similarly, sum of third and fourth triangular numbers is 16, which is square of 4. Can you tell me that sum of next 2 triangular numbers? Yes, of course, it is 25. So, what do you infer from this activity? So, sum of first triangular number and second triangular number is giving 4, which is the square of 2. Similarly, sum of the second and third triangular numbers is 9. Third and fourth will give the sum 4 square. Fourth and fifth will give you the sum 25. Can we generalize this statement? Sum of nth and n plus 1th triangular number is always n plus 1 whole square. So, from this we can say that triangular numbers are associated with square numbers. Now, you may be wondering, can we get a triangular number easily, say 15th triangular number or 36th triangular number easily? So, here we how we got the triangular numbers? We took 1, then we added 1 plus 2, then we added 1 plus 2 plus 3 to get the third one, fourth one 1 plus 2 plus 3 plus 4, fifth one 1 plus 2 plus 3 plus 4 plus 5 and so on. Suppose if I want 25th triangular number, then how can I get? If I go on adding all the natural numbers from 1 to 25, it will be time consuming and tedious also. So, we will have a general formula to get the triangle n plus 1 by 2. You can check, we got the fifth triangular number as 15. So, if in place of n, if you put 5, then it is 5 into 5 plus 1, which is 6 divided by 2, 5 into 6 is 30, 30 by 2 is 15. So, in this way we can get any triangular number by putting n equals to any natural number. So, now let us see how these square numbers are related to integers between them. So, let us check, verify number of integers between two consecutive perfect squares. So, we know that these are the perfect squares starting from 1, 4, 9 and 16. You can proceed further also. Let us take the first perfect square, which is 1, and the second perfect square, which is 4. How many integers are there between these 1 and 4? Yes, these are 2 and 3. So, we have 2 positive integers between the first 2 consecutive perfect squares, that is 1 and 4. 2 and 3 are the non-perfect square numbers. Similarly, between second and third perfect square, which are the non-perfect square numbers? 5, 6, 7 and 8. Yes, they are 4 in number. How many non-perfect squares are there between 9 and 16? 10, 11, 12, 13, 14 and 15. These are 6 in numbers. So, what do you infer from this? One thing we can get is that between any two consecutive perfect square numbers, the number of non-perfect squares is always even. So, can we have the number of non-perfect square numbers between 50 square and 51 square? It is very tedious and time consuming also. So, that means we have to have a formula to find the number of non-perfect square numbers between any two consecutive perfect square numbers. For that, we will have a pattern. Let us take the first two perfect square numbers, which are 1 and 4. Among them, the smaller one is 1, and what is 1? 1 is square of 1. Now, this one we will take and we will multiply it by 2, or we can say we will double it. So, we get 2. So, between 1 and 4, there are 2 non-perfect square numbers. Similarly, among 4 and 9, the smaller one is 4 and it is the square of 2. We will take this 2 and we will double it, I mean we will multiply it by 2 to get 4, which gives the number of non-perfect square numbers between 4 and 9. The same procedure we can follow for the next also. Among 9 and 16, 9 is the smaller one and it is the square of 3 to multiply to get 6, which gives the number of non-perfect square numbers between 9 and 16. Now, can you tell me the number of non-perfect square numbers between 20 square and 21 square? Yes, you are correct. It is 2 times of 20, which is 40. So, there are 40 non-perfect square numbers between square of 20 and 21. So, you can generalize this one. For any natural number n, there exist 2n integers, or we can say 2n non-perfect square numbers between n square and n plus 1 whole square. Now, let us see how these perfect square numbers are related to natural numbers. Sum of natural numbers and perfect square numbers. Is there any relation between the sum of the natural numbers and perfect square numbers? Two examples. One example of odd perfect square and another example of even perfect square. So, first I have taken the square of 3, which is 9, and as we know 3 is odd, its square is also odd, an odd perfect square number. So, what I will do is, how this 9 is related to sum of natural numbers. To get that one, what I will do is, we have to divide this 9 by 2, make it half, to get 4.5. Now, where is 4.5 located on the number line? It is between the two integers, namely 4 and 5. Yes. So, we can say that 9 can be written as the sum of 4 and 5. What are 4 and 5? Those are two consecutive natural numbers. So, here what we have done, we have expressed a perfect square number as the sum of two consecutive natural numbers. So, this is the case when the perfect square number is odd. Is this the same when the perfect square is even? So, let us have an example for that also. So, here I have taken 4 square, which is 16, and as you know 16 is even. So, can we follow the same procedure for this also? Yes. So, let us make it half, or in other words, let us divide 16 by 2. So, if I divide 16 by 2, I will get 8. Now, where you can locate the 8 on the number line? Yes, it is located between the two integers, that is 7 and 9. So, how can I write 16 now? Yes, 16 is written as the sum of 7 and 9. So, 16 equals to 7 plus 9. Are these consecutive natural numbers? No. Yes, you are correct. These are two consecutive odd natural numbers. So, you can see the difference. A perfect square which is odd can be expressed as sum of two consecutive natural numbers, whereas perfect square which is even is expressed as the sum of two consecutive odd natural numbers. We can generalize this. An odd perfect square number, of course, it is greater than 1, can be expressed as the sum of two consecutive natural numbers. If the perfect square is even, then an even perfect square number, again of course, it is greater than 1, can be expressed as the sum of two consecutive odd natural numbers. Now, we have seen that odd perfect square is related to sum of two consecutive natural numbers, and even perfect square is sum of two consecutive odd natural numbers. But more is interestingly, every perfect square number is related to sum of odd natural numbers in a different way. Let us see what is the difference of this one. So, consider the sum of the one odd natural number. Since there is only one odd number, its sum is of course 1, which is a perfect square. Let us take the sum of first two odd natural numbers, that is 1 and 3, will give us 4, which is the square of 2. Here we added two odd natural numbers starting from 1 and we got square of 2. What happens if we add 3 odd natural numbers consecutively beginning from 1? Yes, you are correct. It must be square of 3, which is 9. If you proceed in the same way, sum of first 4 odd natural numbers will surely give you square of 4, which is 16. So, generalizing this, we can say that sum of first n odd natural numbers is equals to n square. Suppose if I want the square of 6, I know that I should multiply 6 with 6. So, I will get 36, which is a perfect square and it is a square of 6. And if I want the square of 11, we have to multiply it with 11, then I will get 121, which is again square of 11. Similarly, square of 15 is 225. So, this is one way of finding the square numbers. Is there any other way to find the square numbers? So, this method is called finding the squares of the numbers using identity. You are very much familiar with identities which we use in algebra. Among those identities, here we are using one of the most familiar identity. Suppose if I want to find the square of 24, you know that square of 24 can be got by multiplying 24 by 24, already we done it, but now we are finding the square of 24 by using the identity. Now, what we did here is 24 is split into two numbers whose sum gives 24. Remember children, 24 can be written as 23 plus 1, 22 plus 2, 21 plus 3 and so on. So, in many ways we can express 24 as the sum of two natural numbers, but here we have selected 24 as the sum of 20 and 4, because the square of 20 to find is very easy and it is very easy to find the square of 4 also. So, whenever you are splitting any number to find the square by using the identity, you should take care of these things. You should split that number in such a way that we can get the square of both the numbers very easily. Now, here what we will do is, we will take the first number, that is 20, and we will consider the second number. So, first we will write the square of 20 and at the end we will write the square of 4. We will multiply the product of these two numbers by 2. So, 20 square 2 into 20 into 4 plus 4 square. Now, you can see that square of 20 is very easy to compute. 2 2's are 4 and there is 1 0, therefore, we have to double it. Similarly, multiplying 2 into 20 into 4 is also very easy. 2 2's are 4, 4 4's are 16 and 1 0 is there. So, it is 160 and we know how to find the square of 4, it is 16. If we add this 400 plus 160 is 560, 560 plus 16 is 576 is the square of 24. We can see that this identity which we used here is a plus b whole square, which is nothing but a square plus 2ab plus b square. Your assignment is, okay friends, myself Shashikant Joshi, TGT, Government Model Primary School, Auradesh, Taluka and District, Bidar. I will be thankful to Swami HR, Assistant Teacher, Government Girls High School, Devanhalli, Bengaluru Rural District. Thank you.